In this session, I will explain you about uh, tools to make a mask. So let's just say we have the data like this. Okay, let's plot in the log scale. Okay, that's the log scale imaging. So in order to average the data, azimuthally average the data, definitely we need to have a mask to remove the beam stop and the kind of the area that doesn't have any data, right? Okay, so here's the tools. Make a mask, click it. Okay, then you will see these tools. The first of all, okay, you need to pick the image. So let's click this button. Then it will load the image from the Saks image viewer. So it's basically the same image, but it's kind of, as you see, maybe image is flipped over and up and down, but that is not important. And the color scale is also different. Okay, but also we can change it. So to set the color scale, let's just change the color scale from, let's just say, well, maybe first we can plot this one in the low scale, and then from 0 to 10 to the 5, okay, like this. Let's just zoom in a little bit. Okay, good. And at the beam 9, already, so the Bender is providing a default mask to mask these Pilatus detectors data gap area. Okay, so how we can do that is load mask. Okay, load mask, click, and under Saks directory, that's a good pix underscore mask. So I select that one, and then don't forget, once you load the whatever new image or new mask, and then you have to add that mask into the memory. So click this button, add to the mask. So that mask is added to the existing mask, but existing mask was actually nothing. So if you show the mask, you will see the those vendor provided kind of mask images, right? So we mask this region out. That's good. And by clicking this button, then you can remove the mask area and then you can see the images. Okay, so things what we had to do is we had to mask this, up region and then down region out. Okay, how we do that is draw polygon. We're gonna draw a polygon. So like starting from here, go there. Okay, like this. Well, you can zoom it in. So as you see, whenever I click the mouse, uh, it actually draw a blue line, which is a little bit difficult to see, but but eventually, okay. So like a drawing like this, you can draw arbitrary line. So I will not actually mask this beam step out for now. I will mask the upper part only. So if you want to do better than what I'm doing, you can expand the images. Okay, and I cut this, go down. Okay, cut this out, and then click here in the empty area. And then if you do the right click, it will be done. So the final point will be connected to the first point like this. So those region is selected, right? But we don't want to mask this good region out. We want to inverse this selection. In order to do that, click this button, invert the selection. Then the outside area is selected like this. So we want to add this one to the existing mask. Okay, so click add to the mask. So now if you click the show mask button, then you'll see the mask so far you selected. Okay, so next step is masking the beam step out. So for this, I will zoom it in this area, okay, to make a better finer mask. So click draw polygon again, and we want to cut this one out like this. Okay, and then after you click the final final point, and then click right button. Okay, then you finish the selection like this. So I want to add that one to the current mask, right? So then show image and show all the mask that I selected. That's the so far the mask that I have selected. So inspect the all the mask regions. Okay, make sure everything is good. I like it. So then you can save this one. This one I will save as an saxmask.bmp. Okay, click save. If you click save, this mask will be saved at the directory where you are at. So you are at the example directory. So it will be saved under the example by click, let's just say save. Okay. And let's go back to the example directory. You see the Sax mask is just, generated. Okay. That's it.